Geometric progression. We've got sum to infinity, so I'm going to put in the from the formula sheet the geometric series formulae, and I've got to show that the sum to infinity is 4 times the first term. First term's a, and I've got to show that r equals 3/4. So for the first part, sum to infinity, that's this formula here. It only works when modulus of r is less than 1, so r as being 3/4 is good. So we get a over 1 minus r equals, that's the rth term, and it's 4 times the first term, so if that's 4a, I'm going to times both sides by 1 minus r, and I'm going to get a equals 4a times 1 minus r, and that will give me, divide both sides by 4a, so a over 4a equals 1 minus r. That'll be, divide top and by a, 1 over 4 equals 1 minus r. Actually, if one take away something is a quarter, then obviously r is 3/4. I could add r to this side and then take away a quarter from the other side, but it gets r equals 3/4. Given that the third term is 9, so that's part 2, the third term is 9, well, the nth term is a times r to the n minus 1, so the third term, n is going to be 3, and so it's going to get a r squared equals 9. That's the third term, and r is 3/4, so a times by 3/4 squared equals 9. So that means a times by 9 over 16 equals 9, and so a equals 9. Times it by 16 to get rid of the 16th, and then divide by 9, and that will give me that a equals 16. And then finally, the sum of the first 20 terms, I'll do it here. We've got to work out the sum of 20 terms, and I've got this formula here, and I could, of course, remember always times top and bottom by minus 1 to get that formula, and that's really useful if r is greater than 1. In this case, it's not, because r is 3/4, and we want to use the left-hand one, so I don't need to use this one here. And I can go straight into using this formula here. So it equals a, which we've just worked out is 16, times by 1 minus r is 3/4, and that r to the power of n, in which case this case is 20, all over 1 minus 3/4. And actually, when I type this into my calculator, I wouldn't put 3/4, I would actually put down 0.75. It's just easier to type in, and that will give me 63.797042, which equals 63.8 to 3 significant figures. And that's question 5 done.